The problem says an arrow is fired at a speed of 30 meter per second at an angle of 20 degree from the top of a 30-meter tower. So from here, which is 30-meter high tower, an arrow is fired at an angle of 20 degree and the velocity is 30 meter per second. Let's say this is 20 degree with the horizontal, and then what will happen, the flight will go like this and then finally it will come down here. So it says how far from the base of the tower does it land. So this distance we have to find. So we can divide the flight path in two parts. One is this one, should be, I don't know, maybe here, yeah. So in this part, let's forget about this line. So one is this much and another is this much, which is this one. So here the flight, this is where it's the same height as, so this one is 30 meter too. So if we want to find this distance first, what we need to find is how long it takes to get there. And we know that halfway through, when the arrow reaches maximum height, the velocity, the vertical component of the velocity becomes 0. So the vertical component at this point, which is the maximum height, which is halfway of this whole path, the velocity will be 0. So if we use this equation, u minus gt, because initially it's decelerating when it's going high, when it's ascending, so v vertical, u vertical, and this will be 0 at maximum height. So 0 here, and initially it's 30 sine 20 degree because vertical, minus g is 9.8 t. So t will be 30 sine 20 degree over 9.8. Now if we want to find the total, how long the total travel path, how long it takes to reach here, we have to just multiply this one by 2. So if we call that, I don't know, t2 maybe, whatever. So if we multiply this one by 2, we will get degree, all degrees, so 9.8, that is 2.10 seconds. So that's the duration, that's the time it takes to reach here. So to find how far is this one, or what's the distance from here to here, we have to just use s is equal to vt. So v will be horizontal component of the velocity, which is 30. The horizontal component of the velocity stays the same, so 30 cos 20 degrees the horizontal component of the velocity, times the time it takes, so that will be t2. So that will be r1 if we call this distance as r1. So r1 will be 30 cos 20 degree times t2, which is 2.10, so that is 59.2 meters. So sorry, meters. So that's there. Now we need to find this distance. How much is this? Let's call it r2. In order to do that, we need to find again how long it takes for the arrow to reach from here to the ground. From, if we call this point B, if this is A and if this is C, how long it takes to go from B to C, and that will be under acceleration, gravitational acceleration, and we can use this equation, h is equal to ut, u vertical t, plus half gt square. It's plus because it's accelerating, it is descending, so it's accelerating. This height will be, since the tower height is 30 meter, so this height is 30 meter here, and sorry, that's 30 meter, and then we need to, uv will be the same as it was initially because it's at the same point, it's the same horizontally, that's the same plane basically. So that will be 30 sine 20 degree t plus half gt square, half times 9.8 times t square. So that one becomes 30 here, sorry 30 here, then 10.26 t plus 4.9 t square. So our equation becomes like this. If we write in terms of a quadratic equation, just arranging the terms in a standard fashion. So the roots will be uh, t is equal to minus b here. Minus b is minus 10.26 because this is b, plus minus b square minus 4ac. So b square minus 4, a is 4.9 and c is minus 30. So like that, and over 2a, so 2 times 4.9. So once we solve this whole thing, we will get a negative term. It's time, so we will discard that. The positive term becomes something like this. I will write a little bit. 26.97 I guess, and then 9.8 here. Sorry, this is 26.32. And once we find the, so it will be plus minus, but we can discard the minus. So t from here, the root is 1.63 seconds. So that's the time it takes from to reach from B to C, from here to here. Now what is this distance? In order to find that, again we have to look at the horizontal component of the velocity times the time multiplied by the time. So that will be R2 will be 30 cos 20 degree times 1.63. So that becomes 44.95. So the total distance from this point to this point, the distance is R1 plus R2, which will be the total distance. If we call it d, it will be R1 plus R2, which is 59.2 plus 45, sorry, this one 45.95. So that will be 105 meter almost. So just rounding up. So that's the distance. That's how far apart the arrow will land from the tower.